Hi, I'm here to do some stoichiometry problems for you. You can see that we're going to do an equation with iron rusting. So iron plus oxygen is going to make rust. The actual formula for rust is Fe2O3. And now we have to balance the equation. Let's go ahead and in front of the oxygen we'll write in A3. Then we'll put A2 here, right? And then it looks like if we've got that, we'll need 4 over here for our coefficients. So our coefficients here are 4, 3, and 2. Now let's say that you have, you are given 50 grams of iron. And you want to find out the grams of oxygen you would need to perfectly react with those 50 grams of iron. Now, it would be great if we could just go 4 grams of iron to 3 grams of oxygen and use those coefficients, but you know we can't. We can't say 4 to 3 because iron atoms don't have the same mass as an oxygen molecule. So the only way that we can go between the iron that we have here and the oxygen over here is we can go through moles. So we will start with, if we have grams of iron, we will, I'm making a little map right now by the way, we could go to moles of iron, and once we have our moles of iron we could go ahead and, using the coefficients, convert that to moles of oxygen. And once we have moles of oxygen we could go and convert that to what we want, which is grams of oxygen. So again, I'm making my little map for myself. Each one of these arrows that I've drawn really means one step. And what I've written right here, or what I've tried to make, is that each one of these is a times a fraction. Each one of those is one step. Now, I think that the next step after the first one, our map, the next step is which we should get the information out that we will need to do each one of these steps, and you can see that we have 3 of them. So the first one, if we're going to go between grams of iron and moles of iron, we're going to need the molar mass. So we're going to need how many grams of iron is 1 mole of iron. And if I look up on my periodic table, I see that my answer is 55.85 grams of iron is a mole of iron. I looked at my periodic table for that one. I didn't have to look up at the equation at all. So that's what we'll use for that first one. For the very last one, let's do that one now. We will have to go from moles of oxygen to grams of oxygen. And again, all we're going to need, it doesn't change what it is, all we're going to need is how many grams of oxygen are in 1 mole of oxygen. And every single oxygen atom is 16, so a mole of oxygen molecules will be 32.00. Please note that I'm rounding off at the nearest hundredth as we are doing. And then, actually, the last thing I have to do is figure out the center step. This center step is when we'll actually go from one thing to another thing in the equation. And like we've talked about, the only way we can do that is by going through moles. So here, let's figure that out. And we have 4 moles of iron, which is going to be, well, not equal to, but that's the ratio for 3 moles of oxygen. So for each one of these arrows, we have, it's going to be in our setup on the bottom, it's going to be times a fraction, and we've just figured out what the information is we're going to need for each one. So now let's set it up. We've got 3, and we're going to start with 50 grams of iron. And we're going to multiply that by 1 fraction to do that first step. And then we're going to need to multiply it by another fraction to do that second step, and another fraction to do the third step. And hopefully in the end, we are going to get into grams of oxygen. So the first step, that's right here, that's the information that we need. And we're going to put the grams on the bottom. You see why? We want that to cancel. So we're going to go 55.85 grams of iron is 1 mole of iron. Remember, this is called the molar mass. And you can see at this point we have done what we set out to do with that first step. The grams of iron will cancel. And if we would stop it right here, what we would have at this point is moles of iron. But we're not going to stop at that point. We're going to keep going on. So in the next step, that's this right here, where we're going to use this information, and we want those moles of iron to cancel out. So what do you think? Where are we going to put? What do we want to put on the bottom? We want to put 4 moles of iron on the bottom, and then on the top we'll put the 3 moles of oxygen. And when we do that, you can see that the moles of iron are going to cancel. And if we stopped right at this moment, we would stop with moles of oxygen. But we're not done yet. The first step got us to moles of iron, the second one got us to moles of oxygen. We have to get to grams of oxygen. So we're going to use this information that we pulled off, the molar mass, and now what's going to go on the bottom? The 1 mole is going to go on the bottom to go ahead and cancel. And the 32 grams will go on the top. And notice that, when we were getting into the mole ratio, and this is the mole ratio, remember? The heart of the problem. Notice that when we were first converting from grams to moles, those grams went on the bottom, so we could cancel them and get to moles. But once we have moles in the oxygen, the grams go on the top, so we can actually get into grams. And let's go ahead and calculate this for ourselves. I've got 50 divided by 55.85 times 3 divided by 4 times 32. And I get 21.5 grams. And I'm going to repeat it because it would be so embarrassing to make a mistake on the video. I'll clear 50 divided by 55.85 times 3 divided by 4 times 32, and good heavens, I get the same. So this is an example problem, and if you'd like some more, well then just let me know.